This was the place you have seen in the media where the water went through the tunnel and did a lot of erosion over here. My name is Ahr Valley. I'm a postdoc in the working group of Professor Lothar Schrott, and the working group is interested in, of course, geomorphology and environmental systems, and my personal focus is on especially landsliding, but also the consequences of severe floods in different environments like Nepal, but since 21 also in the Ahr Valley.
My name is Thomas Roggenkamp and I'm a scientific assistant in the Geographical Institute in Bonn, and I'm working in the working group of Professor Jürgen Herget, fluvial geomorphology, and I was working on historical flood events in River Ahr Valley some years ago. It was part of my diploma thesis, and so this is my connection to this topic, to the flood event, also from 2021. On the 14th and 15th July 2021, we had a major precipitation event, not only in the region of Ahr Valley, also in bigger parts of Western Germany and also Belgium, Luxembourg, Netherlands, also France. And we had some high magnitude precipitations of about 100-150 millimeters in 24 hours. So this was a very big event.
Most of the rainfall has fallen in the upper catchment of the Ahr Valley in the northern tributaries. And due to several factors like the shape of the catchment itself, the topography, the land use, and also the almost saturated soils, the severe flood developed.
Aus der Luft wird die ganze Zerstörung sichtbar. Dutzende kleine Ortschaften geflutet von braunem, schlammigem Wasser. Die Grenzregion Nordrhein-Westfalen, Rheinland-Pfalz, ein Krisengebiet.
So it is my goal to reconstruct historical flood events, the discharge and also of the flood event from 2021, to have a better impression of what could happen and to create better flood maps, for example. When we include also historical flood events, we could be aware of this risk just before some of these major flood events happen.
I'm basically interested in many aspects of the flood, like understanding of why this disaster happened, why so many people were killed, but understanding right from the beginning why the flood occurred, what were the special environmental conditions. We are now here in Sinzig, in the Ahr Valley. This is the Ahr catchment. And well, you see that we have the steepest parts in the Ahr Valley in the middle section, and but we have a lot of flatter areas in the upper parts. And the average yearly rainfall is from at least 600 to 900 millimeters a year.
I mainly work with historical tools. I work with old maps, old descriptions of flood events, old flood marks on buildings, on bridges, to get an impression of the historical water stages. And with these different factors, we try to get all the information we need to measure the velocity of the flood, of the historical flood, and together with topographical information about the flooded area, we can measure the discharge.
We are using quite a range of different techniques. So first of all, we have different data sets of airborne laser scanning. So we have high resolution digital terrain models from before the flood, from after the flood. What we did is that we started to map the trees wanted to know how many trees were uprooted in this section. We are using additionally also drone investigations and structure from motion analysis to study the effects, especially at the landslide, how the landslide is moving, quantifying it. We are using seismometers to get a better understanding which parts of the landslide are moving and if there is some preparation in the underground which we can't see with our eyes. We are also conducting geophysical measurements at the site in Müsch, for example, to get an idea of the structure of the landslide, to get an idea of the depth of the sliding plane, to quantify the potential landslide volume. If we talk about erosion, we analyzed it from just for the part of Rheinland-Palatinate from dorsal to Sinzig in a stretch 60 meters to the right and to the left of the Ahr. And all together we are in the order of 1.3 million cubic meters of soil and rocks which were eroded in a single day.
The discharge could not be increased by anything, but you could have an effect on the catastrophic event. More than 130 people died in the river Ahr Valley because of this flood. So this is a point where you have to think of ideas to get a better warning system in this area, like an early warning system, a warning system that works, that reaches the people living in the Ahr Valley. If this would have worked better, a lot of people would not have died in this flood event.
There was a lot of different factors leading to this disaster. It all starts with the difficulties we have even in short-term weather forecasts. So it was clear that this event will happen in the region, but it wasn't clear which catchment all the rain would come down. But then we had also, due to the magnitude of the event, we have special features which are not considered in flood modeling for flood forecasting. And this is especially the clogging of bridges due to uprooted trees and many other items. And also the non-linear behavior of the whole catchment is a difficult issue. And like drainage systems we have on grasslands, nobody knows the extent of this. And then we got a problem that we had flood hazard maps before for the old 100 years event and the extreme event. And the problem in these maps is that the old historical events were not used in this approach, and the time series is too short, so that the results after applying some extreme value statistics are too low, which means that the flooding area shown in the official hazard maps are too small, far too small. Related to our research, we must be careful with the way we communicate, not to re-traumatize people.
When I started my research after the flood event of 2021, it was just some days after the flood. So I had to be very sensible. I tried to reach some areas at the Ahr Valley to find paleo stage indicators that gave me an impression of the water level of this flood event. So I parked my car at top of the valley and walked down the valley. So try to not to affect anyone. But it changed in the month after that people wanted to talk to me. When they saw me in the Ahr Valley and saw that I was doing some measurements, they came to me and told me their stories, and I had the impression that they wanted to talk about this. And so this was very important also for my research. In the case of the river Ahr Valley, people just forgot about the older floods There was a flood in 1804 and another major flood in 1910 and then 2021. And after all of these floods, people said this was the biggest flood that ever took place in the Ahr Valley. At one building in the town of Dernau, we have such a building with flood marks. And I met a woman that lived in this house or near this house. And I asked her if she knew these marks and if she had a kind of risk awareness because of these flood marks. And she said, no, absolutely not, because these floods were so long time ago. But people should absolutely have these hints in mind, because what happened in the past can absolutely happen again now or in the future. So people just forgot about the other floods. It's the flood dementia. And we have to try to find ways to overcome this dementia. So there are a lot of ideas to reach this goal, like flood museums. There are also ideas like teaching these old flood events in history lessons in the schools in the River Ahr Valley. So people just have to learn a bit more about the own history where they live to get an impression of what is possible.
One of the crucial aspects is the information on historic events, historic extreme events, and the integration into the flood hazard modeling, which would mean that a lot of hazard modeling would have to be redone. And in many areas, I guess that people wouldn't like this enormous extension of flood hazard zones. But anyway, from a natural hazard and risk perspective, this would be absolutely essential to do.
Our goal is to put this approach into other locations, because it's not a unique event. It could happen also at a lot of other areas. So it's very important to get an impression of historical flood events. This is why we don't want to look only on the Ahr Valley, but also on, for example, the River Rhine and some of the tributaries.
I think geographers could do research in any kind of topic related to the flood. Physical geography could still focus on the details of the flood and the flood impact. The role of the clogging of bridges is still unclear. The timing, how the flood developed through the valley is not fully understood. But also the number of buildings in the valley which was flooded and their role in changing the flood behavior.
I get some requests of students. They want to do some own research work in River Ahr Valley on very different topics, like the risk analysis or like comparison of older floods with the recent 2021 flood, and also about the whole process of rebuilding the settled areas. The River Ahr flood showed us that the risk maps that were created some years prior to the event didn't show the real risk that was in this location. So when you are in the River Ahr Valley, you see that the valley bottom is absolutely flat. And maybe with the perspective of a geographer, you may see very easily that this flat valley bottom is the possible flooded area of this location.